Welcome back, guys. This is the homework we're going to have tomorrow in class. I need us to watch this video and pause it every couple moments and try to answer the questions before I actually do. That way we can be most beneficial. So let's read the first question. For each position versus time graphs below, create a qualitative velocity versus time graph. So remember, always look for, am I looking at position or am I looking at velocity? So, because they're saying the same data, but they're doing it from a different lens, so you have to keep that in mind. So for this motion, if we look at here, I'm going at a constant speed, okay? So my velocity is neither increasing nor is it decreasing. So that's what the main thing I got to focus on here is that my velocity isn't increasing or decreasing. So this number here, it's not getting higher and it's not getting lower from here. So the line is going to stay flat because it's my velocity. So I come over here and I draw a flat line, and it's in a positive direction. So it's staying constant in a positive direction. So this is positive velocity, this is negative velocity. Now if you look down here, my slope is going down, so I am staying in a constant speed on letter B in a negative direction. So again, my speed isn't changing in the negative direction. So I go to negative velocity and I draw a flat line too. It's the same thing. Okay, we've seen this one in class a lot. This is a constantly accelerating line, meaning my line is getting faster, or my object is getting faster and faster and faster. So if my velocity is increasing, I need to show that my velocity is increasing. So it would be that line right there. So on letter C, the velocity for representing a curved distance versus time graph is going to be a straight line. If we look at letter D, I'm starting off slow and I'm going faster. I'm starting off slow and then I get faster in the negative direction. So I'm increasing in speed. Okay? Now this is important to note. I'm increasing in speed. So, and it's in the negative direction. This part it would not be correct if I did this, because this line means I'm getting closer to zero velocity. We just said I'm increasing in velocity, right? So I can't be getting closer to my midpoint. I have to be getting farther away from my midpoint. So in the negative direction, increasing velocity, there I go. So imagine this started off as 0 and it ended at negative 10. Can we say that? So it'd be negative 10 something meters per second divided by something meters per second. Now look over here. Imagine it started off as 10 and now it is 0. Same thing here. My starting point here would be 0, so it'd be 0 and minus, my starting point would be 10, 0, and my finishing point would be negative 10. So we know that is going to be your, say, y sub 2 minus y sub 1, where that's going to be negative 10 minus 0 is going to be negative 10. Same thing here for E. Your starting point is 10 and your ending point is 0, so 0 minus 10 is going to be negative 10 here. So again, these two things, even though this one's on the top and this one's on the bottom, I'm still going to have increasing in speed in the negative direction. So I'm still increasing in speed in the negative direction, so I'm going to get the same thing here. I'm increasing in speed, I'm going away higher in speed in the negative direction. So these two things are the same thing. So how would I put that into words? So for letter A, for box A, I go box A. I am looking at this, it's going at a constant velocity. So describe the motion, including direction, and tell if it is constant, speeding up, or slowing down. I am going at a constant speed. It's constant in a positive direction. That's a shorthand, that one, but in a positive direction. This is going constant. Letter B is going constant, as we said, in the negative direction. Letter C is speeding up in the positive direction, while this one is, letter D is also speeding up in the negative direction. And letter E is the exact same thing as letter D. Now, what would it look like to slow down in a positive direction? Well, to slow down in a positive direction, just an example so you can see that. Slowing down in a positive direction, I'm going to just do this for letter D and I'll correct it in a second. Slowing down in a positive direction would be to here, going to my 0 point. Slowing down in the negative direction would be to my 0 point. So that's what slowing down would look like. So that's why both of these are speeding up, because they're going away from your 0 point. Okay, let's go answer number 2. So let's get a different color. Let's get orange. So the question says, the object of is shown in a position versus time graph. Which scenario best describes? Now this is distance, okay? This is a distance versus time, so let's not get confused. So distance, what's going here? There is no increasing distance. You understand? There's no increasing distance. So it's not moving. Not moving at first. It doesn't move. Next, it does move. It gets, this one does move. It moves in traveling towards the 0 point, because this is 0. So from here to here, it's traveling at a constant speed, towards 0. And then the third part, it goes away from 0 at a faster, and then it slows down. So that's slowing down. Right here, this indicates it's going flattening out, so it's slowing down. So what happened here? It didn't move because the time was increasing, but the position didn't change, so that's no movement. And then it went towards my 0 mark at a constant speed, and then it went away from my 0 mark faster than slowing down. So which objects, A, B, C, or D, can show that? Object rolls along. Well, rolling along means that it's moving. It didn't move first. The object rolls along, so let's cross A and B out because they both say. C says the object doesn't move at first. Check. Then slows down, traveling. No, it's sped up. That's the thing here. So it's increasing speed in the negative direction there. And speeds away from X, then slows down. Well, it didn't slow down. It actually sped up towards 0. The object, because it's speeding up, would, again, if it says speeding up, it would indicate this right here. Okay, that's what speeding up means. So if I were to have a curve on my distance versus time graph, that's speeding up. This is constant. So C is wrong. D, the object doesn't move at first. Check. Then travels towards 0 at a constant velocity. Check. And then away from 0 at a constant velocity, then slows down. Check and check. So right now, D is my answer. We'll see if E gives a better one. The object rolls along. No, we agree it doesn't roll along. So the answer to number 2 is going to be D. Okay, number 3. Let's work on number 3 really quick. A car rolls downhill, getting faster and faster and faster, and then continues at a constant velocity, then stops instantaneously when it hits a wall. Which of the following graphs correctly depicts the situation? So remember, it's rolling down the hill, getting faster and faster. So it's going down the hill, going in a negative direction, or I'm sorry, it's increasing in its velocity. So it has to be getting faster. So faster velocity, and then it has a constant velocity, and then it stops. So no velocity. So that means basically right here. So we come. So I track that. And dot, 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 dot. This is my line. Dot, dot, dot. Don't move, right? I'm not moving. Time is going on, but I'm still not moving. So which one of those has a increasing in velocity and then a constant velocity and then stops? Okay, which one of those has the... So I look through here. So our car rolls down the hill, getting faster and faster, then continues at a constant velocity, and then stops. Well, a couple ones that we might think. If we look at E, yes, this is getting faster, okay, and then it slows down and then goes to constant velocity. That didn't happen. It went straight from going faster to constant velocity. That one's not it. This one's getting faster. Well, actually, it starts off fast and then it goes slower. So this one shows that you're actually getting slower. So that's not that one. This one goes back to 0. We're not saying that. It didn't ever actually come back to the starting point. So it went downhill. It never showed going back up the hill. This one right here, you're going at a This one shows you getting at a constant velocity. This one is, this is constant speed. This one shows a constant speed. So this is a no velocity change. So no velocity. I apologize to make sure that this line would represent no velocity is what that line would represent. This is a constant speed right here. Okay, so that would be a no if I wanted that in velocity. This one right here represents a no movement whatsoever, so this would show stopping. Now we'll go last one. This one is getting faster and faster and faster, and then continues at a constant velocity, and then stops. So the one should have been A. Let's go to the next page. Okay, now these are motion diagrams. What we want to make to be clear here is that this is the motion diagram that we are used to seeing. We see the dots and the arrows. So right now we can see that something's going away from zero, getting slower and slower and slower. So that means the acceleration is opposing that. These red lines, these red arrows represent the acceleration. It's slowing down. It's an opposing force there. The idea of inertia, that something's going to have its motion, maintain the same motion unless acted on by an unbalanced force. This is showing the force opposing it. That's why it's slowing down. So where on this motion, this is an xt motion diagram, right? Let's look at what it's going to be, what velocity versus time graph is going to represent this specific motion. Now, I'm going fast, right? And then I slow down going in a positive direction. So I'm slowing down in a positive direction. Which one shows me going forward in which one shows a motion in a positive direction? This is accelerating in a positive direction. So which one shows me increasing in a positive direction? Or, I apologize, yeah. Oh, I apologize, it's slowing down in a positive direction. This right here is positive. This is the other one. It shows positive, and then it stops. And then it stops moving right here at this last dot. So it's slows down in a positive at a. Number 5 says plot a qualitative position versus time graph for the motion depicted in the above diagram. So position versus time. So we agree in the position at 1 second. It's this one's also slowing down. So it starts off fast. And then it slows down. Okay, that's a position versus time graph. It starts off fast, then it slows down in a positive direction. And let's go back to number 4. This one is, does it have a constant velocity? No, it does not have a constant velocity, so therefore it will be sloped downward. A constant velocity would be a flat line. This one is not a flat line because it's not a constant velocity. It's slowing down here. And then you see this last dot right here. At the last point right here, it stops. So this is showing that time is going forward and there's no velocity whatsoever. The velocity has gone down to 0. So the answer is going to be D. Let's go do number 6. This one's kind of difficult, so we'll go through that. If you look at number 6 right here, let's draw a velocity versus time graph. So this is velocity and this is time. What's happening here? At first, you're going at a constant rate in a positive direction. It's slow for sure, but it's a constantly slow in a positive direction. So constant rate, this is a flat line, at a positive direction. And then it stops. So constant rate in a positive direction, and then it stops. So if you look at this little circle here, this indicates stoppage right there. So my motion has stopped. I am not moving anymore. Well, if I'm not moving anymore, then I have no velocity. So my velocity comes down to 0. And time is still traveling, right? This is 1 second. Okay, this is distance over here. This line represents distance, so no distance, right? But time is still going. So I have time still over seconds right here, and then it increases in a positive direction. My velocity is increasing. So that means I have an increasing velocity. So I have a straight line here because my velocity is increased. And then down over here, I stop again. So I stopped for 2 seconds now. So I have a longer pause. Okay. I have a longer pause, so I draw longer. No velocity, and then it goes in a negative direction. In a negative direction, it goes at a constant velocity. So now, in a negative direction, a constant velocity again. There's not going to be a diagonal line here because it's not going a different speed here. It's going the same speed. So here I go, negative direction. Remember back to this other one over here. Remember a constant velocity in negative direction was underneath or past the negative point. Same thing here. So that's the answer to that one. And finally, number 7, a position versus time graph is shown to the right. What would its velocity versus time graph look like? So look what's happening here. So I have a constant, this is shows a constant speed, right? This first part, it shows a constant speed at first. Then it increases, or let's put it this way. From here to here, it's getting faster. We agree? So it's getting faster from here to here. That means my velocity is going to increase. And then it slows down here. My velocity decreases right here. It decreases right there. So it's going to slow down here. And then it's going to come to a stop at this point right here because time is increasing, but it's not increased in distance. So it sped up here, it slowed down here, and then it came to a stop. So which one shows me speeding up, slowing down in a positive direction, speeding up in a positive direction, slowing down in a positive direction, and then coming to a stop? Well, let's work backwards. This one is this one is constant velocity, and then speeds way up. Velocity over time is very fast. This one is goes at a constant velocity. I'm sorry, this is increasing speed, then goes at a constant speed, and then slows down. So D is. C is goes at an increasing velocity. So you're going at an increasing velocity, and then you're still moving, but you go with a constant speed. This one is be constantly speeding up. Well, that didn't happen. And then this one is goes at a constant, increasing in velocity, then it slows down, and then it stops. So it's going to be A. Thank you for listening to this video. I hope y'all guys, this has helped you guys.